right. There we go. There. Done. All right, broadcasting. Welcome. All right, so I figured I'd spend some time doing a little bit of reading today, and I want to get into more of a habit of reading out loud and providing some materials that are more timely. I mean, I'm looking at the simple English version of Wikipedia right now. The idea that I was thinking of doing here is basically picking an article and just reading it out loud for 5 minutes. I mean, it's not going to be too long. This is targeted for language learners who need something that is read by a human rather than the computerized reading that you can get on your computer, but also people who are looking for just something not so textbook-ish. And so the idea is to pick an article, read for a little bit, and that's it. I was thinking about making this also into a podcast to be easily downloaded for people. We'll see when that can get sort of put up, but for the time being, we'll keep with putting this on YouTube as a live stream. All right, so on the simple Wikipedia page here, I don't know, what are some topics? I mean, these are knowledge groups that they have here. Natural sciences. I haven't read anything about astronomy in a while here. Astronomy, okay. That doesn't come up in a lot of tests. We can open that, see what it's like. Applied sciences. Let's look at architecture. Why not? Copyright, defense. We could do copyright. Let's see what copyright is. History, sure. Why not? Philosophy. I won't read all of these. I'll just go through some of them. Animation, maybe that'd be a good one. And I don't know. Wow. I almost feel a little bit odd reading about religions and different beliefs, but no, let's read atheism. Start with A. And what's the rest? Well, other ones, they don't, like, they do have simple, do they have simple Wikipedia in other languages? I don't know, to tell you the truth. That's a good question, if it does that. All right, well, let's see what astronomy is in simple English. Wow, that's quite a bit. I know next to nothing about astronomy other than, well, passing knowledge. Let's put it that way. Analysis subfields of astronomy, solar astronomy, planetary astronomy. Well, last week, was it last week or 2 weeks ago, NASA crashed a satellite into an asteroid, so that's pretty neat. Okay, so let's read this. Astronomy is the scientific study of celestial bodies. That means stars, galaxies, planets, moons, asteroids, comets, and nebulae are studied, including supernovae, explosions, gamma ray bursts, and cosmic microwave background radiation. Astronomy concerns the development, physics, chemistry, meteorology, and movement of celestial bodies. The big questions are the structure and development of the universe. Astronomy is one of the oldest sciences. The patterns in the night sky were called constellations by the Arabs. They used the positions of the stars to navigate and to find when was the best time to plant crops. Astrophysics is an important part of astronomy. A related subject, cosmology, is concerned with studying the universe as a whole and the way the universe changed over time. Astronomy is not the same as astrology, a belief that the motion of the stars and the planets may affect human lives. There are two main types of astronomy: observational and theoretical astronomy. Observational astronomy uses telescopes and cameras to observe or look at the stars, galaxies, and other astronomical objects. Theoretical astronomy explains what we see. It predicts what might happen. Observations show whether the predictions work. The main work of astronomy is to explain puzzling features of the universe. For many years, the most important issue was the motions of the planets. Many other topics are now studied. Daytime astronomy is possible. First, there is the sun, but observing directly is dangerous. It is too bright and can burn your eyes and cause permanent blindness. To look at the sun, you need proper shields and equipment. Some other individual bright stars and planets can be seen during daylight hours through a telescope or a powerful pair of binoculars. There you go. So that's the interesting. Well, let's read the ancient history of astronomy, and I'll move on to something else. History of astronomy. Ancient history. Early astronomers used only their eyes to look at the stars. They made maps of the constellations and stars for religious reasons and calendars to work out the time of the year. Early civilizations such as the Maya people and the ancient Egyptians built simple observatories and drew maps of the stars' positions. They also began to think about the place of Earth in the universe. For a long time, people thought Earth was the center of the universe, and that the planets, the stars, and the sun went around it. This is known as geocentrism. Astronomy is from the Greek astron, meaning star, and nomos, meaning law. Ancient Greeks tried to explain the motions of the sun and stars by taking measurements. A mathematician named Eratosthenes was the first who measured the size of the Earth and proved that the Earth is a sphere. A theory by another mathematician named Aristarchus was that the sun is the center and the Earth is moving around it. This is known as heliocentrism. Only a few people thought it was right. The rest continued to believe in the geocentric model. Most of the names of constellations and stars come from Greeks of that time. Arabic astronomers made many advancements during the Middle Ages, including improved star maps and ways to estimate the size of the Earth. They also learned from the ancients by translating Greek books into Arabic. There you go. All right. Well, read so much, and they talk about the Renaissance and the modern era. Let's continue with the Renaissance to modern era. So we're right here if you're following along on the screen. Renaissance to modern era. During the Renaissance, a priest named Nicholas Copernicus thought, from looking at the way the planets moved, that the Earth was not the center of everything. Based on previous works, he said that the Earth was a planet and all the planets moved around the sun. This brought back the old idea of heliocentrism. Galileo Galilei built his own telescopes and used them to look more closely at the stars and planets for the first time. He agreed with Copernicus. The Catholic Church thought Galileo was wrong. He spent the rest of his life under house arrest. Heliocentric ideas were soon improved by Johannes Kepler and Isaac Newton, who invented the theory of gravity. After Galileo, people made better telescopes and used them to see farther objects such as the planets, Uranus, and Neptune. They also saw how stars were similar to our sun, but in a range of colors and sizes. They also saw thousands of other faraway objects such as galaxies and nebulae. The modern era. The 20th century after 1920 saw important changes in astronomy. In the early 1920s, it began to be accepted that the galaxy in which we live, the Milky Way, is not the only galaxy. The existence of other galaxies was settled by Edwin Hubble, who identified the Andromeda Nebula as a different galaxy. It was also Hubble who proved that the universe was expanding. There were many other galaxies at large distances, and they are receding, moving away from our galaxy. That was completely unexpected. In 1931, Carl Jansky discovered radio emission from outside the Earth when trying to isolate a source of noise in radio communications, marking the birth of radio astronomy and the first attempts at using another part of the electromagnetic spectrum to observe the sky. Those parts of the electromagnetic spectrum that the atmosphere did not block were now opened up to astronomy, allowing more discoveries to be made. The opening of this new window on the universe saw the discovery of entirely new things. For example, pulsars, which sent regular pulses of radio waves out into space. The waves were first thought to be alien in origin because the pulses were so regular that it implied an artificial source. The period after World War II saw more observation. The period after World War II saw more observatories where large and accurate telescopes are built and operated at good observing sites, normally by governments. For example, Bernard Lowell began radio astronomy at Jodrell Bank using leftover military radar equipment. By 1957, the site had the largest steerable radio telescope in the world. Similarly, the end of the 1960s saw the start of the building of dedicated observatories at Mauna Kea in Hawaii, a good site for visible and infrared telescopes thanks to its high altitude and clear skies. The next great revolution in astronomy was thanks to the birth of rocketry. This allowed telescopes to be placed in space on satellites. Space telescopes gave access, for the first time in history, to the entire electromagnetic spectrum, including rays that had been blocked by the atmosphere. The X-rays, gamma rays, ultraviolet light, and parts of the infrared spectrum were all open to astronomy as observing telescopes were launched. As with other parts of the spectrum, new discoveries were made. From 1970s, satellites were launched to be replaced with more accurate and better satellites, causing the sky to be mapped in nearly all parts of the electromagnetic spectrum. All right, we will stop it there with the discoveries, and I had the bodies and the different description of the solar, the planets, asteroids, comets, the galaxies, phenomena. Talks a little bit about the methods, what they use, these telescopes and spectrometers, radio telescopes, techniques, integration, data analysis, Fourier analysis. Fourier analysis in mathematics can show if an observation over a length of time is changing periodically, changes like a wave. If so, it can extract the frequencies and the type of wave pattern and find many things, including new planets. Interesting. Different subfields of astronomy, pulsars, solar astronomy, planetary. That's looking at planets, moons, dwarf planets, comets, asteroids. Galactic astronomy, studying different galaxies outside of our own, including our own. Gravitational wave astronomy, study of the universe and the gravitational wave spectrum. So far, all astronomy that has been done has used the electromagnetic spectrum. Gravitational waves are ripples in space-time emitted by very dense objects changing shape, which include white dwarfs, neutron stars, and black holes. Because no one has been able to detect gravitational waves directly, the impact of gravitational wave astronomy has been limited. There you go, related pages. All right, well, I think that's good enough for now. Hope you guys enjoyed that. And I guess we